We perceive the world around us as distinct and unambiguous and take information for granted. Our perception is our reality. We hold on to this reality, even when we are shown to be wrong. We have seen it, therefore, it must be real. Reality is not what it appears to be. The world around us is ambiguous, noisy, and by no means as distinct as our perception would have us believe. But how does our brain process information? And how is the reality we perceive created? The process of perception is not bottom-up. We must constantly filter the incoming information and grasp the real meaning of the outside world. When it comes to understanding perception, we rely not only on our senses, but also on prior information, such as our beliefs, experiences, and expectations.
When you look at this image, what do you see? Do you see two silhouette profiles or a white vase? This picture is a great example of an optical illusion. An optical illusion is a visual stimuli that is perceived by the eyes and then comprehended by the brain in a way that is different from reality. Why does this happen? Since the brain has a need to define reality based on simple, familiar objects, it creates a whole image from individual elements.
Visual perception may be more influenced by the utility of information than we've ever imagined. A new study suggests cognitive biases can start as early as at the retina level. There has long been a debate in neuroscience. Do our senses offer a full representation of the world, or are they survival tools? The answer might not be what you expect. Previous research showed human perception is far from complete and can be quite selective. And now, researchers have begun to explore the conditions under which these perceptual distortions occur and when they begin. In a new study, researchers found our brains adjust visual perceptions based on our interests, indicating that cognitive distortions can begin at the level of the retina. The researchers designed an experiment with 86 participants, who were asked to repeatedly compare two black and white striped patterns, known as Gabor patches. In the first round, correct answers earned points. But in the second round, the point system was changed. Points increased regardless of the answer's correctness. The participants' assessments of the Gabor patches' angles varied between rounds, revealing that perception was not based on objective reality but rather on how to gain the most points. This finding hints that, rather than being an error, cognitive distortions may be an efficient way for our limited cognitive resources to process the world. Even at the level of the retina, useful information is prioritized. In a twist, artificial intelligence agents exhibited similar perceptual biases when they were subjected to the same experiment. This implies that these distortions may be deeply rooted, arising even before we consciously process what we see. Our perception is designed more for utility maximization than for providing a complete representation of the world. And while this realization doesn't simplify our understanding of cognitive biases, it does provide new avenues for identifying and correcting these biases.